before we talk about Ballerina language first, so let me quickly give a background to the Ballerina project. So the WSO2 is a company that develop open source enterprise integration for last 15 years, or I would say 16 years. So this is where Ballerina came from. So the one of the integration pattern in enterprise integration is ESB. So we were developing this middleware software called ESB for 13 years, and so these are the things we learned from in last 15 years. So when you take enterprise, so now everything becoming digitally innovated, and when it's come to in enterprise, so there are a lot of systems, and in order to digitally innovate, you need to integrate this system with each other. So for example, if you take a typical enterprise, so there are a lot of inventory system, and there can be CRM system like customer relation management system like Salesforce, and there can be cloud services like the Office 365, G Suite, and Google Sheet APIs, and there can be many internal and external services, right? So when you're trying to digitally innovate, so these integrations become very hard, and it's taking time, and it's become very expensive. This is applicable for the all technology vendors. So the Mule is one of the player in this area, and see their report. So I will share this slide later. So they have published these problems. So when it comes to cloud native engineering, one of the key requirement is this integration needs to be very simple, and that has to be run on containers. So if you look at 10 years back, so all the integrations runs on a virtual machine, on servers, and all the running a middleware in a VM it's not an issue. But when you have a lot of integration, so the integration has to be very simple in order to manage, and it will be should be easy to start, and there are requirements like this. So everyone is trying to containerize their integration. So see, there's a great article from Brandon Byers. So this published in Martin Fowler's website. So you can Google search this. So there's a great article called "You Can't Buy Integration." So that article explains all these problems. Okay, so integration is all about programming, but so when it's come to integration, so there are not only developers, there are business users. So business users usually like to understand their business logic, the integration logic. So having a visual representation of your business logic is a must. So domain specific languages, or the DSL, dominated because of this. Because there are so if you take for example, so there are XML and JSON based domain specific languages. There are some specifications as well. So for example, BPMN is one of the famous DSL, and BPL, and likewise there are Camel, Synapse. There are a lot like this. So the one thing they did great is they provide a RIPE abstraction to integrate programming. So for example, they provide how to represent the network service and how to represent endpoint, and they have nice abstraction for routing methods. Likewise, they have a RIPE abstraction for integration programming. But the downside of this DSL language is when you have to do beyond this abstraction, you have to fall back to a normal regular programming languages. Like, so it can be a JavaScript, it can be Java code, something like that. So because of these issues, so the integration programming has lost the software engineering best practices, and because it's very close universe, because the user groups is very small. So now let's look at, we have modern programming language and what they are focusing on. For example, if you take Rust is for writing a lot of internal the highly concurrent programming, like so the Firefox written using Rust. When it's come to Golang, so it's for system programming, and people are writing Kubernetes implementation using Golang because it has performance and it's for system engineering. If you take Swift, usually it's for iOS development, and we see now a trend to implement a server-side application as well. I hope everyone knows TypeScript. So the TypeScript, you can write front end and back end using backend of web application using TypeScript, and Dart is for writing web web front end using Flutter. Likewise, we have modern languages, but none of these languages address the enterprise, the complexity of the cloud native engineering. So why cloud native engineering remains complicated? Let's see. So when you are once you write your application, now in order to deploy into the cloud world, now you have to write some YAML configuration. For example, if you need to deploy into the Kubernetes, you need to write YAML deployment configurations. That's not only. So the security management is a must. The reason is, so in the cloud era, you can't trust network. So the supporting zero trust network is a must, and your code has to be well written and secure code. And then there are other requirements like service discovery. Then you need to introduce service measures and distribute transaction, distribute coordination. These are complicated problems. So why modern language can't support these problems? So we don't have options. So the workaround is to use existing language. The one of the problem we face with the existing language such as Java, .NET, Python, and these are developed before the cloud era. And these are not defined for cloud native engineering. And so then IVC, the Java is trying to catch up with these technologies. But for example, there are difficulties faced by the language designers. Basically, if you in order to add these cloud native features, and you may have to introduce new features, some may request new keywords, and if you add new keywords, it will going to be a maintenance problem, and you need to keep the backward compatibility. There are problems like this, right? So then the solution is adopt framework. So we have frameworks like Quarkus and Micron, and the Spring Boot is one of the famous frameworks, but actually it doesn't solve the problem. It makes the problem more complex. So if you take average developer, so it will become a barrier to enter into this world. So because there are a lot of complexities added by these frameworks and language and the other things. So for an enterprise, this is going to be a problem. So because in order to deliver, in order to catch up with the cloud, in order to catch up with the world, you need to deliver fast. And if the cloud native engineering gets more complicated, it will take time to develop application, and more time means it's more expensive, and the finding developers also become problem because of this barrier. So we start this Ballerina project to address these problems. So the main goal is to create a modern programming language that combines the best of programming languages such as Go, Java, Rust, etc., and the existing integration technologies and cloud native computing into a textual and graphical language that is optimized for integration and with the mainstream potential. So this project started in mid 2016. I was with the initial team, and since then we have spent more than 300 person years investment to date, and language has evolved several iteration. And the one great thing is this language and its libraries, tools, all are open source under Apache license. So if you go to the GitHub to this URL, you can see all the compiler source code, everything. It's all available under Apache license. And the ballerina.io is the website. So if you go to there, you can download and install. So let's talk about the Ballerina language. So as I mentioned earlier, we are trying to take the address the most use case of the domain specific language and the screen languages have, with keeping in mind the scalability and the robustness of the application language have. So this is designed for mass usage and for the production use. It's not a light language or academia. And so designed to support graphical view. So as I mentioned earlier, so this is one of the key requirement, having both textual and the graphical parity in source code. So and this is designed for cloud. And one of the other key areas is this is better include language. So for example, this has a package system, is structured documentation, testing, and a lot of libraries for network data, things like that. So some other languages, these are afterthoughts. For example, Java, the packaging system is afterthought or managed by some third-party systems like Maven. And Go package system came very lately. Right? But in Ballerina from the day one, so we thought about these problems, and language can't win without this ecosystem. So the Ballerina ecosystem has these all things you need. So let's quickly talk about features of Ballerina. So these are I have picked 6 areas: the data-oriented, flexible type, and concurrency and reliability, graphical, and cloud native. So these are not only the features of Ballerina, so there are a lot more, but I'm trying to give an introduction to these areas. So let's quickly look at the data-oriented, what's data-oriented means. Okay. So when it's come to data-oriented, so as I mentioned earlier, so the Ballerina is developed for writing cloud native application. So that means you have to work with a network endpoints, which means so you have to interact with network endpoints. So the thing is, to represent this network data, you need something. You need something like data without some code. For example, if you take objects, so the object consists of 2 things, the data and a behavior. Because of that, object is not good enough to represent this network interaction. So you only need data. So the Ballerina has this plain data concept. So let me explain what plain data means. So the Ballerina has data types like simple data types. So we have int, float, decimal, Boolean, and we have then we have some sequential type called string, XML, and there's a data type called JSON built-in data type. So it's a union of these all the simple types, and and it has the union of JSON arrays and JSON map of JSON. Likewise, so we have defined a data type called any data. So the any data is a union of all the type I described earlier. So you can use this data type to represent any network interaction, the result of any network interaction. So let's look at this example. So hope you can see my mouse pointer. So this is one I have defined a record. So this is a record data type. So the record data type works as a map, right? So the record data type works as a map, but the difference is, so this has a required fields. So if you look at this record type, so it has two fields called X and Y. Both type is float, and this is a float type. So this is how you create a value. So this is how you create a value. So I have given X and Y. So the good thing about this data type, this data types is, so you can easily convert, assign this value to a JSON value. So here you have to do nothing to assign this value. So so in the next example, so you see there's a syntactically difference. It's the same record type, but there's no vertical bars here. So this means this record is open. So this means so this record can work, can have more fields other than X and Y in any time. So but by default, this record is open to any data. So in order to assign this value to a JSON, as I mentioned earlier, so any data contains XML, which is not compatible with JSON. In order to assign that value to a JSON, you can use toJSON function. So that what it does is it automatically converts that JSON value, if it has XML value, and it will convert to a string representation of that XML value, put that as a JSON field. So that's about data. So the Ballerina has non-data types. So we have objects, even though we use objects for internal interfaces, it's not object oriented. And then there are some other types like functions, pointers, stream type, things like that. It's a big type system. So let's look at the other features, how you can use these data types. So here I have defined a record type again. So it has 3 fields and it's open record type: first name, last name, and salary, right? So here you can see this decimal type. So why we have introduced decimal type. So if you are working on a financial related data, so you can't use floating point types, because if you use floating point numbers, you will lose precisions. Because of that, we have introduced this decimal type, so we will preserve the precisions. So and you can simply use that type for your financial application. So this record has an employee. So similarly, you can create an employee array. So let's say you want to query this array. So we have built-in query-like syntax, SQL-like syntax. For example, here is an example. So you can take each one employee at a time, and I'm going to order that employee using his last name and first name and create a new array. Right. So I will do more like example in when I going to do a demo. So this this not only work for arrays, so you can use this for any tabular data. Like, so we have type table type, and we have mapping type. So you can use this query-like syntax in anywhere. And when it's come to XML, so we provide XQuery like querying functionality. And when it's come to JSON, you can use JSON path-like syntax. You can use dot, and you can use dot to navigate between JSON structure. And so there are more features like this, so you can easily manipulate and go through these data types. So let's talk about the Ballerina type system. So unlike in other, so when it's come to type system, so we had few choices. So make it nominal type or a structural type, but we pick structural typing. So what structural typing means, the compatibility or equivalency is based on the definition. Calculating the compatibility or the equivalencies based on the definition of the characteristics of the type. When it's come to nominal, so the compatibility or the equality calculation is based on the explicit declaration and the names. So for example, good example for nominal type system language is Java and Kotlin and PHP. These are nominal type languages. When it's come to structural type languages, Ballerina is a structural type language. Go and TypeScripts are structural type languages. So the reason we pick structural type system is when you are dealing with network systems, you need loose coupling. So and you need to support open structures, and so for example, if let's say you are getting a JSON value from the external system, and you are writing a integration logic route to route this message based on one of the field, right? So that means you don't need to know about all the things you are getting. You only need to know about that specific field, right? So what you can do is you can define a type with that field and make it open, and that JSON value is going to compatible with that type. So when you're writing these kind of applications, so there's a principle called robustness principle. What it says is be conservative in what you send and be liberal in what you accept, right? So keep in mind this principle, so when you are writing application. So language is statical type, but sometimes we provide runtime time checking as well, because if you for example, if you're working with JSON like type, so you need to easily navigate between that type. So to make it easier to navigate, so we provide simple syntax for that, and we provide runtime type checking. Then there are operating. So let's talk about the works for describing for operations in the program performs and data on the wire point. So Ballerina provides some key features like the remote functions, resource functions, things like that, to represent operations in external in external endpoints. And using this operation, so you can create abstraction, like you can create clients or services to represent this data. So also this you can use the Ballerina type system as a schema language. So basically, so when you are going to do data binding, for example, if you are going to do data binding for JSON, so you can use defined types for that particular data, and you can use that for data binding. So language provides the tools to do this automatically, and some libraries will do this automatically for you. So I will explain this concept during the demo. And as I mentioned earlier, so the one of the key design point is we need to have a textual and graphical syntax parity. So this is one of the, so as I mentioned previously, so we have remote function concepts. The remote function concept is using remote functions, we can represent the external operation. So here I have a function called onIssueCreated, right? So these remote functions are modeled as vertical lines in the sequence diagram. So we use sequence diagram to represent our application. The reason is in the sequence diagram, it's very easy to show the interaction between actors. So this remote function is one of the actors. And when it's come to concurrency, we have concept called strands and workers. So workers also act as actors in this diagram, so it will become a vertical diagram. So the horizontal lines, for example, this horizontal line to represent the message sent between these sectors. This is possible because from the day one we designed this language to have this graphical syntax parity. So the other thing is the language provide a great concurrency concept. So as I mentioned earlier, so we have a concurrency concept called strand, and it's somewhat similar to Go routines in Go. So you can think this as a lightweight thread. So to run a strand, you don't require a dedicated OS thread. So basically what happens is, so when you have so we have a strand pool, and so the scheduler picks from these strands, and if strand is ready to execute, it will execute, and if strand is waiting on IO, it take out that strand, and that scheduler will give that OS thread to another strand who is waiting. So it's behave like somewhat similar to Go routines. So the functions can have workers. So if you look at this example, we have worker called TL. So these workers are lexically scoped. So this is the scope of the worker, and this is the scope of the L worker, and the remaining part we call as a default worker. So this is part of the function's default worker. So so you see this arrow syntax, right? So this arrow syntax is message passing between these workers. So let's say in this example, so I want to publish a message to both Twitter and LinkedIn. So what I can do is, so I create two workers, and in two workers, I'm going to send this message to Twitter and LinkedIn. So after that, I'm going to send the result back to the main worker, right? So as you can see, this message passing has to be mapped, otherwise it's a compile time error. So the compiler can detect this has to be exactly match, otherwise we will go into the race conditions. So now let's talk about the consuming network services. So the one of the key feature of the Ballerina is the consume network services, right? So also, so the in the previous slide, I talk about the how to send message between workers. So the message between workers. So the when it's come to network interaction, so we can represent external operation using remote functions. So the this remote function has group by client object. So this SMTP client is a client object, so the which used to send email. So the here I create a client object, and I'm going to call this send email remote function. So there's a difference. So when you're going to call a remote function, so we use this arrow syntax. So this exactly matched to a horizontal line in the diagram, right? So there's a syntactically difference when you call a remote function versus a normal function. So for a normal function, we use dot, and for a normal method, for a remote method, we use this syntax. So the other key feature is Ballerina can produce network services. So when it's come to network services, so there are a key concept like the service. You can define service objects, and you can attach them to a listener. So listener is a protocol specific listener. So mostly provided by some standard libraries, and which receive a network input. And what happens is once it receives a network input, it will dispatch it to attached service object. So there are two types of service objects. One is remote methods, so named by verbs. This is to support RPC style. For example, RPC style service is gRPC, web sub, and the webhooks related services are all have remote methods. So the other type of services are you are trying to represent a resource in the we are trying to represent a resource, and these resource have a method name and a noun. So method is for how to access this method. For example, in HTTP, you can have a get as a method, how to access this resource, and noun to represent the resource. So the type, for example, HTTP is a GraphQL, all are falls under to resource type services. Okay, so we have this service object. So here in this example, we have a service declaration. So this example, we have a listener, inline listener, which is HTTP listener bind to port 9090, and it has one resource, and this is the method, the get, and this is the resource name. So resource name. So once you run this service, this service will expose under base path slash, and the resource name will be hello. And this has one parameter call name. So this is going to be a query parameter. So during the demonstration, during the demo, I will write some few services like this. And if you want to, so when you are creating a service, there are basically two approaches. So usually, the most commonly used services like the HTTP GraphQL has the interface descriptors, like the one for HTTP we have Open API, and GraphQL has its own descriptors. So the one way to create this service is using these service descriptors. So there are Ballerina command. So you can, we have the Open API tool, Graphical tool. From that, you can generate a service skeleton out of that. The other way is you can write your service from the bottom up, and from that you can generate the service interfaces. There are tools for this. And let's say if you want to override the metadata about the service, and you want to enforce security, then you can use annotations. Some libraries, for example, HTTP library provides HTTP service config annotation. From that, you can enforce the how to protect. You can engage security, and if you want to override some cloud deployment values, you can use cloud. You can use cloud annotations. Likewise, using annotation, you can override some of these properties. So the next thing is the ability to support cloud requirements. So this again a simple HTTP service. So the Ballerina, so when you're building a program, so you can provide this -- cloud build option. So what happened is, so by default, it will generate Kubernetes and Docker artifacts, and it also create you can use this cloud.thermal file to change the generated artifact values. So let's talk about the reliability and the maintainability. So I'm going to talk, quickly go through this concept, the concurrency of transaction and error handling. So as I mentioned earlier, so we have concurrency concept like strand workers. So, but when it's come to accessing a mutable stage, we make it simple to keep the a familiar programming model. But so, for example, if you are for example, if you are trying to access a common shared mutable state concurrently, that can lead to data races, right? So the one problem is it can lead to deadlocks, and it can lead to incorrect results at runtime. So these are the problems when you encounter when you're trying to mutate a mutable storage. For function workers, so we handle this by allowing all the strands run on cooperatively multitasking on a single thread. That's for function workers. That is not enough when you are going to run when you are working when you're writing a large application. Then you will need some more features, and the type system has to support this. So the type system provides read-only support. So basically you can mark a value as a read-only value. So by marking that value as a read-only, by marking that value as read-only, we can guarantee at compile times no one can write this value at runtime. So it's safe to run on a multi-threaded or multi-strand environment. So then we have something called isolated. So you can mark some variable as isolated. So then to access isolated variable, so you have to acquire logs. So there are key features built into the language, into the type system, to make it concurrent safely. So for example, if you are writing let's say you are writing a service, and the compiler can detect if whether the service has enough logs to run this on a multi-threaded environment. If not, the compiler gives a warning. So I will show you one of the example when I going to do a demo, right? So the other thing is this transaction. So if you're writing a database application. Let's say you are talking to multiple databases. Having a transaction manager is a must. Otherwise, if one rolls back, you will end up with having inconsistencies in the databases. So Ballerina provides a transaction statement. So it's what you can do is, there are transactional aware remote actions. So you can call these transactional aware remote actions inside this transaction state, and that will take care of handling transaction. So but keep in mind, so this transaction statement is not a transactional memory. So let's say if you are modifying, if you have modified some mutable storage inside transaction statement, that's not going to revert once the transactional is rolled back. Right? To support this feature, so the Ballerina runtime includes a transaction manager. So then you don't have to do anything extra. And the other key feature is, so let's say you want to infect transaction in a distributed environment. So we have that support. We have that support as well. Let's say this is very useful. Let's say you have two services, and two Ballerina services, and both of these services are talking to different databases. And if you want to put those this handling data, let's say this handling that data logic into single transaction, you can mark this service as a transactional service. So then the caller will pass the transactional data along with that. So it will so we have this distribute transaction spec written by us. So using that, you can associate these two transactions into a single one. So the error handling. So the error handling is also plays a big role in language design and the usage. So before talking about the error handling, so let's talk about what are the errors we can face in a typical program. So there are normal errors. So normal errors which are related to your business logic. For example, if you are facing a data binding error, if the value is invalid, or if you are doing some file operation and if file is not there, those are all normal errors. And there are another kind of errors which are we can call them as a system errors, like out of memory, stack overflow, and basically end of the world kind of scenario. So for those errors, let's talk about the normal errors first. So the normal errors, when you're writing a typical integration application, so those are normal. So because since you are dealing with the network, you are expect to having such errors. So to represent these normal errors using exceptions. So if you are familiar with Java, so we use exception to represent errors, right? So the problem with this exception is the control flow is not implicit. Sorry, control flow is not explicit, it's implicit. So it leads to hard code is very hard to understand, and it's very hard to maintain using exception. So what modern language application and system language doing is, so the control flow, they make the control flow to be explicit. For example, Go, Rust, Swift, they return these application errors as return values. So the scripting language typically use exception, but in Ballerina we follow this similar model as Go and Rust. Normal, the error flow has to be explicit. That has to be written from function. So for the system errors, we use panic. So similar to Go, out of memory error is going to model as a panic, right? Because you can't do nothing about that. So the one thing is I forget to mention. So we have a error data type. So you can represent error using using this type. So let's talk about handling errors. So let's say when you encounter an error, so what are the things you can do? So there are three things. So first thing is you are trying to handle we are trying to handle the error. Then and there you are trying to do something different. The other thing is you can't go beyond that error. So simply you don't know how to handle that. So what you can do is you can simply return that to the caller, saying you can't recover from this error. And the third option, which is the dangerous option, to simply ignore it. So what happens is if you try to ignore an error, so that can lead to unintended behavior, or even you will get incorrect result at runtime. So in this example, so I have a function called main. So this is the one of the endpoint in the Ballerina language, and I am calling a function called send email. The send email function is here. So send email functions returns error or nil. So these question marks represent error. Question mark represent the nil value. So basically, this function returns error or a nil value. So if let's see here. So if send email send returns an error, we check what's the type of the error. So if it's error, we are saying we are trying to do some saying the error sending the email. Basically, we are trying to handle that error. If not, we say the email is sent. This is the good example of handling error. And here, in the send email, so what we do is, so let's say the SMTP client, when you're going to create a SMTP client, it validates, right? The host name and username. Let's say this host name is has an invalid value, and this creation of the SMTP objects going to be returns an error, right? So we have this I mean so it's not a, we can't do, so if the SMTP client creation is failed, so we can't go beyond this level. So because of that, we are trying to simply return that error from here. So we have this special expression called check. So if you have an expression which returns an error, which has a return, which has a error as a type, so what it does is it will remove that error, and if the expression is evaluated to error value, it simply return from that function. So these are some high-level features I want to cover today. So the one thing is I want to, before going to the demo session, so I want to highlight the Ballerina is meant to be a familiar language. So we follow the C family language, C++, C, C++, Java, and TypeScript like language. And the reason behind this is, so we want to reduce the barrier to learning this language, because if you are familiar with one of the C family language, so the understanding of the language concept is very easy. So as I mentioned, so Ballerina is not just a language, it's a full platform. So we have VS Code plugin, and it supports both source and graphical editing, and it has debugging capability. And we have a lot of tools to like OpenAPI, GraphQL, and and gRPC tools to generate these schemas. And we have a Ballerina Central, that is our module sharing platform. And if you want to deploy this Ballerina program, so WSO to provide a commercial service, it's free to use. It's called Choreo. And from that you can get the observability, and you can do CI/CD and DevOps all under one roof in Choreo. So the current status is, so we did our 1.0 release 2019, and we did the recent release, the 2201, which is code name is Swan Lake. We did this release a few days back. So this is a new major version. So the implementation, so we have a thing called JBallerina. So the tool chain is written using Java. So so this is the main what we have right now. The source code you write is compiles directly into Java bytecodes and runs on the JVM. So also we have Java interoperability. So you have the ability to call Java functions using the Ballerina syntax, and it's available. This is what we available, but this is what we provide right now. The future is we are providing in Ballerina. So it's cross compilation to the native binaries. So that we use LLVM to generate this. And the tool chain will be shared initially. So the compiler front end will be still Java, but it will fully bootstrap soon. And the plan is to provide a C foreign function interface. So basically you should be able to call C functions using Ballerina. So there are pre-release available now. It does not support the full language, but it supports only a few subsets. So this is the version I'm using for this demo. So as I mentioned earlier, so Ballerina, we have Bell. Let me quickly show the help command. So we have several commands, like you can use Ballerina build, run. So you can use Ballerina build to compile the current package and generate the executable, to run, to compile and run. And we have test command, doc command, and pack. There are a few more. Like if you want to create packages, we can use new. And if you want to pull packages from a Ballerina Central, you have pull, push, and you have Ballerina search to search command. And there are some other commands like gRPC, Open API, bind chain, and we have a REPL, interactive REPL runtime as well. That's called shell. Okay. So this bell command is self-updatable. So you can use this command dist to update your current distribution. So let me quickly create a project, Bell new demo. So okay, let me open this using the VS Code. So by default, it will create a main program for you. And then we have the dev container. So if you're familiar with GitHub dev containers, so you can use, you can commit this in the GitHub project, and you can open this in the GitHub dev container. It also supported. And we have the Ballerina TOML file. So this is the place where define the metadata about your package. So as you can see, the observability is included, and the distribution I'm going to use is 2201, right? So as I mentioned earlier, so the VS Code plugin itself has a graphical view. So if you want to open the source view, you can click this one, right? So this is a very boring example. So let's quickly go through what we have here. So the first thing is the import declaration. So this is how you import a Ballerina module. So there are two things. One thing is Ballerina packages and Ballerina modules. So in Ballerina Central, what you get is Ballerina module. So the Ballerina package is a mechanism to package multiple Ballerina modules, right? So here the Ballerina. So what I have created is a Ballerina package. So this is Ballerina toml is for Ballerina package. So Ballerina package has by default what do you call as a root module. So this is the this main bell is part of the root module. You can add sub modules to this project using bell add command. So if you take module, so if you can add modules using bell, even using the VS Code. So yeah, so I'm not going to add any modules for now. So this is the import declaration. So module has two parts. The one is organization name. So this IO module is coming from the Ballerina organization, and this is the module name. So this also works as a module prefix. So Ballerina, so in Ballerina we have multiple entry points to a program. So main function is one of the entry point, and since this is going to be called from the outside, this main function has to be public. So here I have, so we have IO. So this is module prefix. So basically we qualified. So using colon, so you should be able to see all the visible symbols of this IO module. So the println is the one of the functions provided by the IO module, to which you can use to write into the standard out. So this is the simple hello world. Let's quickly run this program. Right. Either you can call bell. You can bell build. So if you use bell build, so it will generate a Java file. It will generate Java file under target directory. See, and you can use bell run target bin demo. Right. So either you can compile and run, or you can build a jar and run that separately. Okay, so now I have explained the hello world. So let's look at how to consume a web service. So for this, I'm going to use another module called Ballerina HTTP module. Right. So once you add this import, the compilers say this is an unused module prefix. The reason is, so we are trying to avoid the mistakes developer face, right? So for example, let me define an integer variable, and the compiler complains this. Let me close this one. The compiler will say this is an unused variable. So by experience, so this is a conscious decision to give these errors. This by experience. So if you have an unused variable, which means there's a bug in your code, right? So to prevent users, so we give these errors and warnings. Okay. So now let's use HTTP client. So I'm going to call HTTP client. See, So this requires, this has a URL. So for this demonstration, I'm going to call this COVID data API. So this COVID data API is provide the details about the countries. So I'm going to use this. I'm going to create a client. So by HTTP clients, if you look at the return value of the HTTP client, it will return a HTTP client or a client error, because if the URL is empty, so we can't create a client, right? So we need to handle this error. So the simple way of handling this error is, I'm not going to handle this one. I'm going to return this error. So now I will get error. So since this this error is returning from here, so my main function needs a return an error. Okay, now we all good. Now let's try to call this service. So this how you call a remote method. So we have the remote methods like the get, post. There are HTTP methods. So I'm going to use get. So what I'm trying to get is this COVID data, countries data is the path. Okay, as you can see, so what I'm getting is some sort of a JSON array, and it has a lot of fields, right? So because I'm getting a JSON data, right? So if you look at the return value of this get method, it returns a type, a target type, or a HTTP client error. So since we need to handle error, I'm going to put check here. Okay, now everything is good. So as I mentioned earlier, so the compiler complains that I have unused variable. So I'm trying to use this variable here, println. I'm going to print the first value of this data. Let's run and see. Okay, so see, so I get the data here. Now let's look at our graphical representation. So as you can see, so while I modify the diagram, so it's automatically update the diagram. So okay, now let's try to do something interesting here. So I want to, let's say instead of JSON, now I want to bind this to a type. So let's say I want to calculate, let's say 1 case per people value for each country. So for that, so let's create a type called country data. It's going to be a record value. It's going to be open record. So because I'm trying to capture the country, cases, and population. So it's going to be a string country in cases, population. Let me verify. Okay, Mola integer int. Okay. So now I'm going to do is instead of JSON data, I'm going to replace instead of JSON, I'm going to use the country data. So now I should be able to access country without any issue. So let me quickly run this application again. Okay, so let me quickly remove this one. Okay, so now let's say I want to transform this data into something like, so let's create another record type. Uh, so this is going to be a closed record type. So now I'm going to capture this string country and some value. In cases per person, right? So now let's try to transform this data into the cases per person. For this, so there are multiple ways. So let's try the easiest way. So to generate this data, so I have to iterate over this data and create a constructor array containing this object, right? So I'm going to create an array data 2, it's going to be empty array. So I'm going to for each country data C in data. So now what I want is calculate the cases per person. And so for that, I'm going to let me quickly reload this window. Okay, so now plugin is all loading. Sorry. Population is going. It's going to be divided by cases. Somehow these agents are not working. Okay. Now we have calculated the cases per person, but this so since we are dividing to integer values, we are not getting the correct result. The reason is if you take integer division, it will round to the nearest integer, but what I need is the upper value. So in order to do that, so what I'm trying to convert this to a decimal. Right, so now I have 2 decimal values. So the reason I'm doing is in Ballerina, there is no implicit conversion between numerical types. So you will get an error saying the incompatible types accepted accepted int but found a decimal type. So the reason I use decimal, so because I can perform the beta division, and I can call a decimal language function to get the ceiling value. Right. So now still I have a problem. So now I can convert back to the int. Now I should be able to get the correct integer value. So now let's construct the cases per person record. So I have field called country. So this is going to be c.country. And we have another field called cases per person. So this is going to be cases per person, this value. And now I'm going to insert this into the okay. Now I have created this value. Okay, let's quickly run. Somehow there's a delay in getting suggestions. Yes. Yeah, this has to be pushed. Thank you. Okay. So this is a typical way you write converting a data, but this is not optimal way how you do this transformation. So as you can see, so I get now the transformation is completed. I have transformed this that huge JSON into a somewhat similar. So let's try to convert this into a, so as you can see, there are 1, 2, 3, 4, 5 statements I have used. So now let's try to convert this into a single statement. So using the language integrated queries, right? So before that, so let me quickly show you the diagram. What I have. So as you can see, I have this nice diagram here. So let me quickly show how to write the same 5-statement logic in a one single statement using language integrated queries. So I'm going to create data. Let's say this is data 3. So I'm going to use this country data C in data, and now I want to convert this. So for this I'm going to use a temporary variable called let me quickly copy this logic here. So I'm defining a temporary variable called case per person, and now I'm going to select this value. Okay, so this is a simple way of writing the same 5-statement logic using language integrated query. So if you want to put some, if you have some condition, you can use where you can add where clause here, things like that, right? So even we can simplify this logic. So we have the built-in data binding capabilities. So here we simply take data value as a country data. So here what we can do is, instead of taking that as a single variable, we can data bind it here using let's say country cases and the population. So then you don't need to use this C dot, you don't need to access that as a member access. So you can simply use that as a simple variable. So let me quickly run this data as well. Let me yeah, so I get the same data. So now let's look at how we can write. So we look how to consume a network service. So now let's try to see how to produce a network service. So for the same thing, I will use the HTTP. So let me quickly comment this out. And so for this one, so let me quickly create a service on HTTP listener. So the service is, the base path of this service is / and I'm going to expose this using the port 9090. And let's try to add some resources. So for this one, let's use the our VS the low code editor. So let me quickly add some resources. So the service I'm going to expose is, let's say, music service. So let's say I'm going to expose album. This will give you all the albums, and return types for now, let me say JSON, and it will add the resources. And let's design let's add few more resources. And I'm going to open the advanced view. So this is the albums, and now I want to get the particular album. So let's add this parameter, type it string based on artist. Okay, so I don't have any query parameters. If you wish to add some query parameters, you can add it like here. So those will become function parameters. And now for this one, let me say JSON for now. Let's add another resource. This to update album. So let me say JSON again for this one, right? So when you modify your the low code view, so it's automatically update the source view as well. So let me switch back to, since we are running out of time, so I'm going to use the source view. So let's create a album record with this is going to be a clause record. So we have an ID, int ID, string title, string the artist, and decimal price. Okay, so this is the album I'm trying to expose. This is the data type I'm going to use for this service. So to store albums, I'm going to create a local storage for this. So for that, I'm going to use a tabular data. So we have this table type, album, and data. So this is how you create a table value. Now we have problems. So in order to make this data searchable, so I need a key. Because of that, I'm going to pick ID as a key field. So I'm going to make this as a read only, and going to provide the key as read only. Okay, so let me quickly duplicate this one, make this as an ID. I have duplication, so I'm going to use a different path. Okay, so now we have this. So let me quickly have some values for this one. So ID is 1, title is ABC, artist is 4, price is something like missing. Okay, I think I have covered all the things. Okay, yeah, let me quickly duplicate this. So since I made the ID as a read-only field, so at the compile time we can detect. So this has the price. We can at the compile time we can detect if there are some duplicate keys. So as you can see, the compiler can see there are duplicate keys. So I'm going to modify these keys for. Let me quickly change to 1, 2, 3, 4. Change bar. Yes. Okay. So now let me quickly expose this data. So far we don't have any errors. So you can see there are no errors. So let me quickly show get to array. So let me return this as a as I'm going to expose all this data as an array. So when I call the get album resource, it will return the all thing as array. So as you can see, I'm returning a JSON value, but we can do better here. So we can simply change this to album array. So I'm missing semicolon here. Okay. So once I do that, you can see there's a warning coming out, because this resource is trying to access a mutable, globally accessible, mutable storage. Because of that, so the compiler detects this service is not safe to run parallelly. So then we mark this service as an unisolated service, and then at the Ballerina runtime, the scheduler see this is an unisolated service and this is not safe to run concurrently. Because of that, the all incoming requests are dispatched to this service sequentially. So there are ways to overcome to make it concurrent, make it parallelism. So basically, you can define this table as an isolated service, and you can have proper you can have proper logs to acquire. You can use log statement to acquire this immutable storage. From that, you can make this service isolate service. So I think I don't have to cover those today, but let me quickly complete this service. So here I'm getting an artist. So for this one, I'm going to use the album. It's going to be an array. So I'm going to use query language again from. Sorry, let me change it to result. I'm going to data bind this artist in data where artist equal. So let me rename this. Artist equal artist name, and select okay, select the so since I think in this case it's better to not do data bind here, simply use the album, because I need to select the I have to simply return the album again. Select album. So similar to the previous examples, I'm going to change this to album arrays, and I'm going to return this data. So get albums. So we can simply use this key field. So here what we get is a simple result. So one single result. So let me quickly write a logic. If data has key this ID, we are going to return that ID. Else, I'm going to create a So in this case, since that ID is not exist, I'm going to simply return an empty album. Sorry, let's return a nil value for simplicity. So the best, so in this case, the best option is to return a relevant HTTP error message in this case, instead of returning nil. But for the time being, I'm using a nil value. For the post section, so in the post, we are trying to update this data table. Sorry, this this table, right? So let me. So I made a mistakes actually. So we need the album payload album. So I'm going to mark this as a HTTP payload. Sorry. So then the incoming request automatically data bind to album data type. So now let me quickly check if album, sorry, if data has key. ID, then we need to give a proper error message here. So if let's say in my business logic, so I'm saying we can't update existing data records. For that, the best option is to provide a proper HTTP error message. So let me quickly change the type to album. So in the successful scenario, I'm going to return the album again. And if there's a conflict, I'm going to return a HTTP conflict message, right? So then I'm going to return. So I'm going to create a error message saying ID ready exists. Else I'm going to update the album. And return the same album. Okay. Okay, I think all are in order. Let me quickly run the service. I am missing something here. Okay. So as I mentioned earlier, so this is giving a warning saying, okay, I think I have a service running somewhere. Okay, now let's try to invoke this service. So if you send albums, it will give the old data. So if I if you give the artist name, it will give that artist name. Then I'm going to give some ID like 5 is not existed. It will simply send. So that is wrong. So I have to handle this error here. Instead of giving, we need to give a proper HTTP. Probably maybe a not found error here. So that is wrong. So if I give 3, so that will give the ID. So let me quickly change this to post. So this one is expecting a JSON body. So what will happen is, so if you send a empty body, it will give a error. So that because we expect a JSON payload, album payload here. So the album has a few things. We have ID. Let's give 5. Mass. See, so if I try to send it again, so I will get there's a conflict.